All right, translations and reflections. These are types of transformations. And transformations are change the position or the size of a figure. And we're just going to talk about ones today where it just changes the position. So translation is like a slide, and that's when a point, a segment, or a polygon or a figure is going to just slide over to another position. So imagine a point just sliding over, or people on a slide sliding on over. All right, sketch a little graph with me, and if you have graph paper, it makes it nice and easy. If you don't, just be pretty neat. So I'm going to put a point at, let's say, -2, 1. That means left 2, up 1. Whoops. -2, 1. That's why you always check your work. And let's say I wanted to slide that. I'm going to call that point A. So label that point A. And let's say that we slid it over to this position. And let's say that point is a apostrophe. I use apostrophe to show the image. That's what that's called. It's the image. And these aren't really a line. I'm just going to connect them with a dotted line to show that I moved them. And a little arrow there. And that A stands for our pre-image. That A apostrophe, it's also called A prime, stands for our image. And the way we're going to use that terminology is pre means before. In this case, before it's transformed. And then the image stands for after. That's what that apostrophe means. And actually, we could add more apostrophes if we were to take that same point and slide it again. Like if I put it over there, that would be a double prime or double apostrophe. But we'll get into that later. Now in this example we just did, we can say that A is translated, and we need to, just like with slope, we need to include two different numbers there because we have a horizontal direction and a vertical direction. And how far did that go across? Well, let's count. It went 1, 2, 3 across, or 3 to the right, and it went 1 unit up. So I'm going to say, I'll say A is translated 3 units right, 1 unit up to become A apostrophe or A prime. Now, arrow notation is basically just explaining that a different way. So we just wrote it out in words what happened. But now I could say like A, point A, which is, in this case, -2, 1. So you just put the ordered pair. Becomes, and I can use an arrow for that, for becomes, A prime, or A apostrophe. And what was that new point it became? Let's look at it. It was right 1, up 2, so 1, 2, right? So 1, 2. And that's how I would describe that transformation in arrow notation. Now there's another way we could say that. If we were writing a translation rule, then that would work for every possible point that we could translate. So we'd have a rule to fall back on. And that way is just using x and y. So we would say x comma y. And remember, x and y stands for our left and right, and y stands for our up and down. And we use that same symbol, that arrow symbol. In other words, x and y become. And what am I doing to the x? Let's look back up. Remember, my x-axis is horizontal, my y is vertical, so my x part is going to the right 1, 2, 3. Another way to say that is it's adding 3. It's going in the positive direction. Remember, these are all my positive x values. Those are my negatives. So it's going positive 3. So I would say x plus 3, comma. And then what's my y doing? Well, it's just going up 1. Well, up 1 is in the positive direction. My positive y's are up, my negative y's are down. So I would say y plus 1. And that's what writing it as a rule looks like. All right, let's try an example with that. So what does x, y, and then x minus 3 comma y actually mean? Well, if we're subtracting from x, that means it's going which direction? On my x-axis, which way is subtraction, or negative? To the left. And then the y, there's nothing after the y. So that means it's not going anywhere up or down, so it just stays there. So really it just means it's translated left 3. Three units. All right, let's do a visual example for that. Let's see if it can make sense using some angry triangles. So look at these triangles that we have here. They're on a, and you can just watch here. You don't need to jot this down. Let's say you have a triangle here, and we have, that's 4, 1 for that point. That one is right 1, 2, 3, 4, 5, 6, 7, and it's down 1, 2, 3, 4, so 7, negative 4. And then this point here is right 1, down 4, so it's 1, negative 4. And then let's say I wanted to move that figure over there. Oh no, we have two angry triangles. So these angry triangles, where do they become? Well, let's look here. I moved that one up 2, and I moved it left 1, 2, 3. And if you'll notice, I did the same thing from this point. I moved up 2, left 3, up 2, left 3. So I'm always moving it the exact same amount. It's always 2 and 3. And I could write that a number of different ways, but the way I would write it is using the rule. And these points would represent like A, B, and C. That's where we started from. And I need to be consistent if I'm going to label these. I would say A apostrophe or A prime. And then this one would be B apostrophe. That one would be C prime. So now we could say XY becomes, what do we do to the X? Remember, X goes left and right. So we went left 3. If we go left 3, are we going in the negative direction or the positive direction? That's right, the negative direction. And the Y, remember, up is positive and down is negative, so we're going up 2. That's in the positive direction for Y. So we would say Y plus 2. And that's how we could write that rule for the angry triangles. All right, now let's jump over to reflections. Please stop looking in the mirror and look at the video. Jeez. Well, not that reflection, but sort of. A reflection is kind of the same thing as when you look in a mirror. It gives you the mirrored image of it. So a reflection is a flip. That's why when you look in a mirror and you see your right eye, it really looks like your left eye, doesn't it? It's kind of backwards or flipped from where it normally is. All right, and then a line of reflection is just an imaginary line an image is flipped over. Or in this case, right, a pre-image would be flipped over, right? The image is what comes afterwards. All right, I'm just going to make a little graph. You can do that with me. And we'll just make it pretty simple here. I'm going to go right 1, down 1, right 3, down 1, and then right 1, down 3, making a right triangle. And let's say that that is reflected over, let's just write up here, reflected over, and x equals -1. Well, remember, x equals -1 is when the x value is always -1. Remember, here's x, so -1's right there. So I'm going to go left 1, but it's always left 1 no matter what the value of the y is. So this is my dotted imaginary reflection line that I'm making. And if it's always going to be equal distance from that line. So how many units over, how many units is each point from there? Well, let's look at this point. It's 1, 2 units. And I'm going to give these points some names. So I'm going to call this one W, V, U. Go Mountaineers. WVU. So we have WVU representing our points. And it's 1, 2 units. So I'm going to go 1, 2 units and put a point there. For my new W, my new W is W apostrophe. And now I'm going to look at this V. The V is 1, 2, 3, 4 units away from the line. So it's 1, 2, 3, 4 units over here. So I put a dot there. I'm going to call that one a V, but this one has an apostrophe because I transformed it. And then this U is 1, 2 away, so it needs to be 1, 2 away from the line over here. I'll call that one U apostrophe. And now I just connect my dots. And you can see that's a mirrored image, just flipped. All right, we're going to let it snow for a second. All right, some objects have reflectional symmetry. And that's when an object can fold over onto itself and it doesn't overlap. So for instance, this snowflake, we could draw like a dotted line right through the center, and you could notice that this would fold over there, this would fold over there, and these halves would fold over onto themselves. Okay, so it is symmetrical. All right. I'm going to draw a few more. So we could fold it over onto itself there, fold it over onto itself there. You see any place else we could fold onto? Well, what if we cut it in half right here? That would fold over onto there. That would fold over onto there. And that would fold over onto there. So it's got several more that we could look at. And if we can do that one, we could do this one. And then we could do this one. Am I missing any? I think I've got them all. So now when you count them, you have to be careful because this is one line represented straight through there. The second line, whoops, that would be our second line going straight down the center. The third line, right through here. You only count them once is what I'm trying to say. So the fourth line of symmetry is right there. The fifth line is right through there. Sixth line's right through there. And then once we start getting to seventh, you can't call that one the seventh and say it goes through, because we've already counted that one as our first one. So you only count them once. So lines of symmetry are just divide an image into two congruent halves. And I'm going to add to that careful to only count once. Be careful to only count them once. All right, well, we can do that. If we've already counted it up here, we don't count it down here. That makes sense. All right, let's just do one example with that, and that will wrap up our lines of symmetry. Draw an equilateral triangle, and then just use dotted lines to draw all the lines of symmetry. Why don't you pause the video and then check it with me. All right, let's see what you got. Dotted line right through there, there's 1. Dotted line through here, there's 2. And then 1 right through there, there's 3. So there's 1, 2, 3 different lines. It helps if you number them too, so you don't get them confused. Well, geez, that was too easy. Let's do one more example. We'll do a square this time. And again, pause the video and then try it with me. All right, let's see what you got. 1 going right down the center, 1 going down through the middle. And then did you catch the diagonals? For a square, you can, this doesn't work for a rectangle, but for a square, you can go right through the diagonals there. So we have 1, 2, 3, 4. 4 different lines of symmetry. All right. And snow is pretty to look at, but no fun to play in, especially in the springtime. Yeah, it's fun in the winter.